Hello guys, so today we are starting our relational database lecture. So today we will only study the advantages of relational database. So the first advantage that we have seen is the strong data integrity. So how relational databases like MySQL, one is a famous relational database, MySQL, Oracle, right? They provide the relational database service. So how they maintain the strong data integrity? So using the primary key, foreign key and the unique constraints. Okay. So what is primary key? So primary key is the key which is unique across one table. Okay, which is unique across one table. So suppose we have a person table, right, where we have person ID, right? We have ID, suppose ID card, the person's ID card. Suppose we are maintaining Aadhaar here, right? So this person's ID will be unique across all the data. I mean, suppose one ID is 123, so this ID another persons cannot have, right? So it will be completely unique for all the persons we have added in person table. So what is primary key? Primary key is the unique key, right, and that is completely unique across all the data in that particular table, right? So person has name, mobile number and address ID. So instead of maintaining the full address here inside the person, what we did, we created another address table where for each address there is a address ID. So for this address table, address ID is the primary key. So that means for this address table, address ID will be the unique across this address, right? Now it has pin code, state, district, city, house number, right? So but this address ID, where we exactly we are referring? We are referring in the person table, right? So that means this address ID is a foreign key, for this person table, and this person ID is the primary key for this person table. So using these constraints, what happens, right? So any persons first adding his details, right, has to maintain one address ID. So before, suppose in this address table, address ID present is 123, 124 and 125 address ID is present in the address table. So these are the valid addresses, right? So after validations only we are adding data in the address table, and we have 3 address ID present in the address table, right? So in that person table, when the person data is storing, right, so the person ID may be 00001234, okay, and name is Amit and mobile number is 97 ... and the address ID he cannot put 126, right? This is where the insert query will fail because of the constraints, right? Because this foreign key what we are putting 126 has to be present in the valid address table, that then only we can maintain this address ID. So what will happen here? The integrity of the data that we are putting in this address ID will always be maintained with the valid address ID which we are having in the address table. So that's how they are maintaining the integrity of the data. So and the next one is this primary key will always be unique, so that no duplicate person can enter the value or can insert the data inside person table. Same also, right, for one particular address ID, no duplicate data can present in this address table. So this is how we can maintain non-duplicate record in those tables. Okay. So another thing is unique constraints. Suppose you have the mobile number, right, and you created one unique constraints. This length of mobile number cannot be less than 10. Okay. Suppose you have added like this. Okay, length of mobile number cannot be less than 10 or has to be equals to 10. Okay, has to be 10. Okay. So length of mobile number has to be 10. Okay. Suppose these unique constraints you have added in this person table. So what will happen, right? Whenever any new data is coming to enter in the person table, it will check this constraints is kind of satisfied or not. If we are trying to enter a mobile number of 9-digit mobile number, this whole insert will fail because this constraint is failing. So that's how also you are maintaining integrity of the data. You are rejecting the wrong data to get entered in your system. So that's how in relational database you have a strong data integrity maintained in this SQL. Okay. So the next big advantage is ACID transactions. So what happens in ACID transactions is ACID means atomicity, A means atomicity, B means C means consistency, I means isolations, D means durability, right? So I will just give a high level overview. So atomicity means, okay, for a particular transaction, database transactions is what? A set of query, okay, a set of query. Suppose you are inserting first order details in the order table, then you are inserting the payment details in the payment table, then you are inserting, after the payment success, the order gets success, right? The order is success. So insert in order, insert it payment details, update the payment details, so payment is success, then you are updating the order, that order is success, right? Suppose just think, right, if order insert query is success, payment query is failed, okay, or payment query is also success, but payment details is not updated, right? So payment details got failed, update got failed, some issues are there, update order got failed, just any of these, right? Then this payment will be success, order will be success, then half of this particular work will be done, right? So what this particular transactions provides us as a security is either it will execute all these particular statements in a particular transaction successfully, or it will not execute any of them. So that means after the order insert is success, if the payment insert got failed, right, what will happen? This order insert also will get rollback, okay, will get rollback. So what exactly transaction is? So either all of the insert query or all of the query under one transactions will be processed, or none of them will be processed. This is what the atomicity means, okay. So that's why this transactional use case gets fulfilled properly with MySQL. So all the banks loves this MySQL database because they can maintain a proper data data integrity and proper transactional integrity also. So I will have a detailed video about ACID transactions later on in this series. So what is consistency means? Here consistency means as you can see, right, we are able to maintain the complete data integrity, and we can maintain the consistent data also using this integrity, right, using the constraints that we have, right? And another is the isolation. Isolation means how you can isolate, okay, the data access between two transactions. Suppose we are running transactions 1 and transactions 2, transactions 1 and transactions 2. Suppose they all are accessing a common data, okay. That means suppose transactions was in updating, it has not completed the transactions, in between transaction 2 also trying to access it, whether it will be able to access or what level it can access or what level it can update. So we have couple of isolations level which actually kind of provides isolations between two transactions. We have a detailed video later on in this series also related to isolations. So we have in the MySQL the isolations feature, right, so that two transactions can have a boundary between each other, that what they can do or how what is the access level for this particular transaction to a common data, okay. So next is durability. MySQL is completely durable. Suppose you have once you committed a data, the data is forever, okay, you cannot erase it, okay. Once you committed a data, even though after commit the database got crashed, right, the data will not be forgotten because the commit happens in your hard disk, database hard disk, right, and hard disk data never gets forgotten in case of database getting crashed. So once the committed data, once the data gets committed, it will be forever until you manually go and delete it, it will be forever, okay. For any database crash, it will never be deleted. So it is completely durable, okay. So next is we have a powerful query language. For relational database, we have a powerful query language called SQL. So this SQL is the most commonly used query language, and it's very powerful because it has select query, right. So using this select query, we filter out data based on certain conditions, right. We have join query, where it happens we can join multiple tables using foreign key, or we can join multiple tables using foreign key and get the extract data. So this is very powerful join, right. And group, we can group the data based on certain columns also, we can aggregate data based on certain columns, we can update it. So insert, update, join, group, there are couple of powerful queries are available, even a lot of more couple powerful queries are available in this SQL query language. So it's also very big advantage of using MySQL, because you can run complex joins, you can run complex grouping, aggregations, a lot of things, right? So another thing is schema. The most beautiful things is you have a very strong schema in this SQL relational database. What is happening? You have a very fixed schema. So fixed schema for a particular table. So whenever you go in a table, you can see what are the data can come to this table and what is the type of data can come, because every attribute in your table will have a data type, right? So that's how also actually this maintains the data integrity, because if you put any data column as an integer, always the integer value will come. If you send any data out of integer, right, this database will reject the data. So we have complete fixed schema and the complete data type also to maintain a complete data integrity. And MySQL doesn't support flexible schema, okay? It works with the fixed schema. So you have to first know what data exactly you are storing in a table, then only you can create a table with that particular schema and what are the columns available, then you can insert the data. Not like MySQL that there is flexible schema, no schema available, anything you can put, you can dynamically add or delete whatever you want. So, and one other thing I already told, most RDBMS database have strong mechanism for restoring data after crashes, right? That's what I told, because whenever the crash is happening, only the forgettable memory like RAM and all the data is getting deleted. But whenever you are updating anything in the hard disk, right, it will never be deleted, right? And whenever you commit any particular transactions, all the data gets written in the hard disk, not in the RAM. So what happens, whenever any crash is happening, right, the committed data will never be forgotten. So the restoration is also very easy in MySQL. So these are the basic advantage of RDMS. Okay, we will have a separate video for this ACID, because it's a very important topic for in MySQL. We will have completely separate video for each of these ACID properties. So stay tuned and see the next lectures. Thank you so much.